Hi there, it's Jason Gorman from Codemanship with another video on our series on codecraft for Python programmers. In this video we're going to be looking at refactoring. Refactoring is improving the internal design of code to make it easier to change without changing what it does. So we're cleaning up our code without breaking it. And it's one of the most important disciplines in software development, in my experience. The ability to reshape code without breaking it is hugely valuable. Whether you're working on legacy code or whether you're test driving new code, the ability to keep that code readable or to make it easier to read, to make it simpler, to remove duplication, to deal with dependency problems without risking breaking the code, very valuable and very undervalued. You don't often see it mentioned in job specs or at job interviews, even though it's absolutely essential if you want to keep your code easy to change. And if you want to be agile, if you want to be able to respond to changing requirements, then that's absolutely essential. So it's a very important discipline. And it's a word that's overused a lot and abused as a term quite a lot. But in this video, we're going to demonstrate exactly what refactoring is and how. I'll show you how I do it. So the example I'm using here is our Mars rover. So I've test driven some code to drive a Mars rover over an idealized XY grid that represents the surface of Mars. And we can turn the rover left or right. So if, for example, if the rover's facing north and we turn right, then it ends up facing east. And we can move it one square backwards or forwards. And we drive the rover by sending it sequences of these instructions: R for right, L for left, F for forward, and B for back. And we interpret that sequence. And for each of those instructions, we execute the right command. And it's all working. Let's just prove that. I've got a little batch file that runs my Python unit test tests. So I'm going to run that first of all. Very important in refactoring that you've got to keep the code working. And before we do any refactorings, before we make any changes at all, just make sure that the code is working. So I'm going to run my test script there. We should have 17 passing tests. So that's a good starting point. The tests are our safety net for doing refactorings, and we don't want to do any refactoring or make any changes if there are holes in our safety net. So think of it in terms of safety is very important in refactoring. As you see, I'm going to be using these tests a lot to make sure that I'm not breaking the code, or if I do break the code, I'll know straight away and I can fix it or revert the code, which brings me on to our next sort of safety topic. Version control. Version control is very important in programming generally. It's like seat belts for programmers. So if we make a mistake or we go wrong or we go down a dead end or something and we're not happy with the code the way it is, we need to be easily able to get back to a working version. And for that, you can use undo and that kind of stuff, and that's fine, but it only gets you so far. It's only so powerful. And the ultimate undo ability we get with version control. So I'm using Git. I've got this on a GitHub repository. And before I do any changes, I do any refactorings, the first thing I do is make sure I've got a backup. So I'm gonna try committing this, and we'll see. Let's put our seat belts on. You'll hear me using that phrase quite a lot. I do like that phrase. Let's put our seat belts on before we do anything, before we go on any kind of journey. And it will probably tell us, no, it didn't like that. Okay, I know why. Because I made a boo-boo, a typo. Git commit should be that. So it should be anything that we've, with anything that we're tracking, basically. Now let's try it. Seat belts on. And it'll tell me there's nothing, basically, we've not made any changes. So we're all backed up and we're all at the latest version. So that's good. So our seat belts are on. If we break the code, it's going to be very easy to get back to a version that passes the tests, a version that works. so we can begin refactoring. Now, you can approach refactoring from different angles. I often think in terms of design principles, but one way that a lot of people approach refactoring when they're cleaning up their code is to look for what we call code smells. Code smells are signs of sort of increasing disorder and entropy in the code. They're signs that the code is rotting. And if you read Martin Fowler's book, Refactoring, it talks a lot about these code smells. I'll post a link to the book, by the way, in the description below. It's a book that is well worth owning. It's one of a handful of books I think that every programmer should own a copy of if you want to be a real software developer. So code smells are signs that our code is getting more complicated, it's getting harder to read, there's more duplication or redundancy or that kind of thing. And then there are almost like, think of them as recipes, these things called refactorings, and they're very well-defined rewrites of the code that you can think of in terms of sort of atomic transactions. The idea being with every refactoring, and they all have their own names and their own mechanics, is at the end of that refactoring, we should be able to see our code work again. So we say that these refactorings are behavior preserving. The code still does what it does, we've just changed the structure of the code. And we're going to see some examples of these refactorings as we clean up some of the smells in our own code here. Starting with, well, here's one thing that I'm really not happy about. We've got all our tests in this test module here, but we've also got the implementation of our Mars rover in the same module. So this is a code smell called divergent change. This module has two reasons to change. It's test and implementation. I can imagine wanting to refactor my implementation but not change the tests, for example. And when we have code in the same module that we can imagine changing at different times for different reasons, it's probably best in the long run to have that code in separate modules, so we only have to change one module, we only have to retest one module, and there's no risk of breaking code that's got nothing to do with this that we don't need to change. So what I'm going to do is I'm going to move my Mars rover to a different module, to its own module basically. And I can do this manually. Now I'm aware that a lot of Python programmers don't use IDEs like PyCharm, and we'll talk about that a little later. So some of you may be using more kind of stripped down editors, simpler editors like Vim or VS Code, and they don't have a lot of support for automated refactorings. So to demonstrate this to begin with, I'm going to do this first refactoring manually, and so I'm kind of showing a bit of solidarity here. Let's imagine I can't do this automatically. What I'm going to do this manually is I'm going to cut my code for the rover class. Let's do that. So we'll cut that. Let's take out a bit of empty space there. And then what I'm going to do is I'm going to create its own module. I'll put it in the root folder just to keep it simple. No, we don't need a new folder, do we? We can just put it in the root. So we need a new file is what we need. So let's create a Python source file. Let's call it Rover. And that's going to be where our Rover class goes. Now, that's not a complete refactoring. To complete this refactoring, when I've moved this thing, I need to go back to my test module and I need to import our Rover class so that this code works again. And that's one complete atomic step. It's not finished. In other words, I can't see this code work again until I've done it as a complete step. So now that that's done, I immediately rerun my tests. And we've got 17 passing tests. So we're back at working code again. And now that we're back at working code, now's the time to make a backup. We've just achieved something useful. I'd like to keep that. The danger is if I carry on at this point that I muck it up and then I lose all of my changes. So let's add this new file. So we should be tracking that, and let's commit that. And I'm just to describe the refactoring I'm going to do there. Moved Rover class to own module. Okay. And off it goes. So seat belts on, basically. So we're safe now to continue. Well, let's consider this Rover class. Let's take a look at it and see, well, this method execute here is pretty long and pretty complicated. So this is a code smell called a long method. And what we can do is we can break that method down so that rather than having all the code in the same method, we can have this method called helper methods. These would probably be private methods, in this case inside the Rover class, that do each part of this work. So for example, if instruction equals R, do this. Well, this is the code for turning the rover to the right. So if you're facing north, it turns it to the east. If you're facing east, it turns it to the south. So we could kill two birds with one stone here. We could break down the execute method by extracting a helper method for turning right. And we can also use the name of that method to describe what this code is doing, because you'll notice the word right doesn't appear anywhere. So this time I'm going to do this using automated refactoring. So let's take a look at the menu of refactorings that are available in PyCharm. That's one of the reasons why I love PyCharm so much. So we have a bunch of refactorings here, and there's one called extract method. It's got its own shortcut as well. And that can be applied to this method. All of these refactorings can be applied to certain things. So they can be applied to a method, or to parameters of a method, or to the name of something, the name of a class, or the name of a variable, or the name of a field. So they all kind of have a context they can be applied to. You'll kind of get a feel for what these things can apply to as we go. Extract method can be applied to anything that can exist inside its own method. So that could be a block of code like this, or a single statement, or just an expression, something that could be contained within in its own method. Let's choose extract method. It'll ask for a name. So right, we want as a verb. And when I click OK, what it's going to do is going to do all of it. So if I was doing this manually, I'd have to cut this code, paste it into a new method, and then write a line of code here that calls that new method. I'd have to do that as a single step. The IDE will do all of that for me, which is rather a good thing. It takes out a lot of the donkey work. Also, if I'm not sure how it's going to look, it gives me a little preview there, for example. I get a feel for how this is going to look. Let's click OK and see what we get. Okay, so it's done it all in one go there. It's saved all the files as well, hopefully. And at this point, what do? We run the tests. It's done a whole refactoring there. Yep, and you run the test as soon as you can. See that it works. Get back to working code as quickly as you can. Let's just take a quick look at what it's done there. So it's extracted that into its own method. That's probably redundant. There we go. And having done that, deleted a line of code, immediately run our test, and that's looking fine. A bit of formatting to worry about there. Let's just keep the editor happy. There we go. And again, run the test. So you see the kind of methodology here. I'm running the tests and running the tests and running the tests. Now that we've got that, let's put our seatbelts on. Let's commit all the files that we're tracking. So extracted write method from rover dot execute. So I'm being quite verbose and quite descriptive about the refactorings that I'm doing. We'll see later why it's a good idea to do that. Okay. Super duper. So seatbelts are on. The code is working. We are good to go for another refactoring. So let's do the rest of these. So there's a method for turning left. Off it goes. Immediately rerun the tests. All the tests are passing. Lovely. Put our seatbelts on. Rover.execute. execute so we know where we made the change. Looking good. Seatbelts on, yep, brilliant. And we continue. So this is, I'm being super, super cautious here, and it's all about safety. So I'm taking these baby steps. The tool is helping me by taking out some of the donkey work of completing these refactorings. And I'm being super, super fastidious about running my tests after each refactoring, and then using version control to make sure that if I need to go back, if I boo-boo later on, it's going to be easy. Extracted. Forward method from okay, so our seat belts are on, and there's one more to do here, which is going back. So baby steps, super, super cautious. Put our seat belts on. Okay, so far so good. Okay, interesting that it thought that, didn't think that was redundant. Let's see why. So while I'm being super cautious here, I'm also being quite bold sometimes. And that boldness, that courage, if you like, comes from the fact that I've got my seat belts on. I've got that suite of tests that are giving me confidence. And I've got backups. I've got versions I can go back to quite easily if it all goes wrong. So I'm treating everything as an experiment. And that makes me more adventurous, strangely, because I'm being more cautious, because I'm taking less risks. Okay, now, what else have we got here? So execute, I've broken it down, but it's still not looking right to me. What we've got here is a bunch of if statements, a bunch of conditionals. And whenever I see a bunch of conditionals that are kind of a bit like a mapping there, I think, well, let's use a map instead. So I'm going to do a refactoring here, which is called replace conditional with polymorphism. So if you notice, right, left, forward, and back, as methods, they all have the same signature. They take no parameters. They have no return values, really. So it should be possible to do this dynamically and map to each of these methods based on the instruction, whether it's right or left or forward or back, and execute it from there. So let's do a bit of typing now. And what I'm going to do is create a dictionary that we can use. So we've got right and left. And I'm going to use a lambda to map this onto a function. So self right, for example. So hopefully you can see what I'm doing there. And left. Oops. So I'm kind of experimenting here, but I feel safe in doing this because it's going to be very easy to get back if I need to something that works. Forward. And back. Now, I've done quite a bit of typing there, and I'm feeling a little... So I'm just, even though I haven't completed this refactoring, I'm just going to say, well, at this point, the test should still run. So let's just make that all fine, all good. So I'm getting back to working tests as quickly as I can. And now what I'm going to do, all I have to do is look up the appropriate command based on the instruction and execute that. So let's Run our tests. Lovely. Wow. So a little adventurous, but I think hopefully you'll agree that what we've ended up for is a bit more self-documenting. R means right, L means left. It's more dynamic, and it's going to be easy to extend as well because because it is more dynamic. It's kind of data-driven now, rather than being all those nasty if statements. So I'm happy about that. That's a nice refactoring. Let's commit that, because there's a nice bit of design that's gone on there. And we'll find as we do these refactorings, we end up introducing these kinds of abstractions. And that's where quite a lot of the design decisions getting made. I'm making design decisions, but I'm doing it based on the code in front of me, fixing those code smells. Okay, so I placed ifs in Rover execute with lambda dictionary. Let's call it a lambda lookup. Lambda lookup. There we go. Off it goes. And that is good, but there's still more to do. I mean, we've got all of these nasty if statements in the other helper methods as well. So let's start cleaning up some of those. This one, for example, well, what's the pattern here? If we're facing north, we go west. If we're facing west, we go south. So if imagine we've got a compass, which is kind of like a circle. We're moving around that circle clockwise from north to west, west to south, and so on. So I think we could actually do something quite dynamic here. We imagine our compass as an array, for example. And all we'd be doing as we turn is we're moving to the next one, the next direction in the compass. South and east. So that's the kind of the orientation of our compass. If we know which way we're facing, in that compass, then all we do is move to the next one with one little wrinkle. So it's the current plus 1. And that would work for the first three, for north, west, and south. But what if you're facing east? Then you're going to go over the end. You're going to go out of bounds, aren't you? So what we need to do here is we need to go back to an index of 0. And one way to do that would be to use mod 4. So if your index is 3, in other words, if you're facing east, and we add 1 to that, 4 mod 4 is 0. So it takes us back to the beginning, if you like. It takes us back to north. So that replaces all of that. And again, I'm being a little adventurous there, but that's fine because we've got our seatbelts on and we have the safety that we get from running these tests over and over again. So that seems to be working. Looking at the right method, it's similar, but the only thing I can see different is the orientation of the compass. It doesn't go northwest, southeast. It goes anti-clockwise, northeast, southwest. So the only thing that's different is that, which means that this is going to be the same. The only thing that's different is this. So what we could do here is we could extract this into its own method. Let's just call it turn. And that accepts the compass as a parameter. There we go. And now I'm just going to inline that. So we're going to replace the variable with just the literal, with the actual array, because we don't need that anymore. Let's test that. And now what I can do is I can replace the implementation of our right method here, reusing turn with a different compass, with a compass that goes the other way, north, east, south, west. Okay. And immediately we rerun our tests. Okay. Let's put our seatbelts on. Replaced ifs in forward and back with array lookup. Okay. So there's a lot going on here. Let's sort of move stuff around a little bit. So let's move it so that left and right immediately rerun our tests. I'm not going to commit that because it's not a big change. So there is more that we could do here. So we could do something similar with back and forward as well. So there might be a dynamic solution there involving, for example, for whatever direction you're facing in any S or W, we could look up a vector. So if you're facing north, the vector would be 0, 1. And in other words, add 1 to Y. So then I can imagine dynamic solutions that would remove those nasty if statements. But I think that's probably enough to demonstrate. Hopefully you get an idea of the discipline of refactoring. It's all about safety. Each refactoring is a small baby step, an atomic step, if you like. They have very well-defined mechanics, most of them, that you might do. And at the end of each of those refactorings, after each baby step, you should be able to see the tests pass again. So you get into that habit of running your tests. Version control becomes very, very important because you need to be able to get back to any working version easily if anything goes wrong. And that extra caution actually can make you a bit more adventurous with your design decisions. You can try stuff out. And if it all goes wrong, that's fine. You can go back to when you were last happy with the design and make sure that it's still working. Now, there's one more thing that I just want to take a look at here. Let's maximize that so we can get a good look. If I look at my Git log there, so we've kind of got this history now. It's almost like a refactoring history, or think of it as a bit like an undo history. That one allows us to sort of step back through all the decisions and all the changes we've made, all the refactorings we've done, so that if anything goes wrong, we can get back to any point or any point in the design with working code. But I've often found that this kind of information is quite useful anyway. It is useful to be able to understand the decisions that have been made and why the design is the way that it is. So it's a kind of a historical design document. Now, at some point, I'm going to push all of these commits to GitHub, and I wouldn't do that anywhere near as frequently as I've been committing. But generally, when I've achieved a higher level goal, for example, if my goal was to refactor the Rover class, then I might say, okay, well, I'm happy now with the Rover class, so I will push that. And that means that I'm then sharing those changes with the other developers on the team. And it is a good idea to do that relatively frequently. What goes very badly is when you do like a week of refactorings or a day of refactorings or hours of refactorings, and you're making lots and lots and lots of changes. So lots of small baby steps can add up to some pretty big changes. And if you spring all of those changes, structural changes, maybe you've deleted folders or renamed files or whatever you've done, on the team in one big batch, in one big dollop, if you like, it can be an absolute train wreck. You can really mess them up. So don't do that. You don't need to be pushing every minute or every 2 minutes, but push pretty frequently. And I think as a rule of thumb, have higher level goals. Like I'm going to refactor the Rover class before I move on. And when you've achieved that goal, then push. And when you do push, again, opinions differ on this. There are some people who don't like having all of these commits in their master repository. So what they do instead is they will squash all of those commits into a single commit, which they will then push. Now, I personally, that's not my style. I like to preserve this history of refactorings. I find it useful for all sorts of things, to understand how the design's evolved, to understand the developers. You can tell a lot about the way that a team works by looking at their commit histories. But also, if you want to practice refactoring, and here's a tip, if you're practicing test-driven development, you can start with a blank slate, basically, and it's very easy. Practicing refactoring means you need to have code that you can practice on. And whenever I've coached developers in refactoring, it's been really, really useful if the phrase that we use is bottling your code smells. So the idea is basically that you need, if you eliminate a long method, then that method is gone forever. But if you've got it in version control, and if you've documented which version you did that refactoring, that specific refactoring in, you can go back to that. You can check out the version before that, which is the one that still contains that code smell. And that makes it very, very easy. Just by searching through your commit histories, by searching through your Git logs, you can find examples of long methods and large classes and long parameter lists and all of these code smells. And they're ready to practice on. And you can also look at what other people did. You can do a diff and go, oh, that's what they did. So you can learn a lot from these logs. So I tend to preserve them. And then when I push, I will label that version. So everything that I'm pushing, all of those commits are labeled so that they are easy to spot as sort of larger grained sort of changes to the software. So how you do it is up to you, but the things to remember are refactoring is cleaning up the code to make it easier to change, so making it easier to understand, making it simpler, removing duplication and all that kind of wonderful stuff. Refactoring is executed as a sequence of refactorings, and each of these refactorings, we can take a look at the menu here, for example, for the names of some of them, like move and rename and so on and so forth. So there's lots of different refactorings, and they apply to different things in code. Some apply to everything, like the names of everything. Some apply only to methods, some apply only to classes, and you'll learn how these apply if you try them all out. And I recommend you explore any refactoring menu you have. If you don't have automated refactorings, you've got two choices. One is to learn how to do these refactorings by hand, and that's fine. But if you want to speed yourself up a bit, take a look at a more full-featured IDE. I know that they can be a bit bloated in terms of the code and stuff, but there are reasons why they're a lot bigger and generally a little slower. And one of those reasons is automated refactoring. It takes quite a lot. It's a lot of number crunching involved in that. Safety. That's the final message with refactoring. Take those baby steps. Keep running those tests. Always be running the tests. And keep your seatbelts on. So after every change that you're happy with, commit that so that you can easily get back if the next one goes wrong. And that will give you the confidence to experiment and try stuff. Because if it all goes wrong, you've only wasted a few minutes. There you go. So that's the refactoring discipline. Super, super important. Takes a while to learn. There's a lot more to it than I've given here. I strongly recommend reading, cover to cover, reading Martin Fowler's book. There's lots of great stuff in there. And don't just read it. Try out the refactorings. Look for the code smells that he describes in your code. And try out those refactorings, because it's a bit like riding a bicycle. You can only learn to ride a bicycle by riding a bicycle. You can't learn it from a book. So get lots of practice. You will need to be a bit organized to practice refactoring, because, as I said, you'll have to find those code smells. You can write your own, obviously, your own kind of idealized version of long methods. But ultimately, you want to practice on real production code, on your own code or on open source code. And that means you're going to have to be able to hunt for the kinds of code smells you're looking for. And also, get a sense, learn to recognize those code smells. A lot of developers, for example, will look at code that's full of if statements and duplication and go, well, I don't see what the problem is. So you need to learn why those things are bad, and it helps if you spend a lot of time maintaining legacy code. You will learn why those things are bad. You will feel it. Learn why they're bad, learn to recognize them, sort of develop a nose for those code smells, as it were, so that when you see them, you're like, okay, that method's too long or it's doing too much, and you know how to fix that problem. Okay, there you go. There's the refactoring discipline. Coming up over the next few days, there's going to be a bonus video about refactoring where I'm going to be exploring and demonstrating a bunch of the automated refactorings that are available in PyCharm, just so you can get a look and see what kind of things it can do. And that's it. Stay safe, and see you in the next video.